All right, let's get going. Welcome everyone. In today's webinar, we are going to discuss about GitHub Copilot, everything you need to know. And what is GitHub Copilot? So GitHub Copilot is an AI-powered coding assistant that helps you write code faster by suggesting code, completing functions, and answering questions directly in your IDE. Now, first we need to understand what options we have in GitHub Copilot. You can run GitHub Copilot in either agent, ask, or plan mode. And let's have a good understanding of what every mode of running means. Now, the first one usually use this ask, and what ask does is you prompt the Copilot and it answers your instructions, but it doesn't apply any changes for you. And the other option is agent. And what the agent does is you prompt for instructions, but the agent does answer your questions, and at the same time, it implements the changes for you. And the last one is plan. Now, I use plan when I have to deal with complex scenarios. So what I found is if I put GitHub Copilot in plan mode, what it does, it goes and fetches a lot of data before doing any reasoning. So if it's a complex task, it does it fetches a lot of files before it proposes a suggestion. What you'll find is when working on a complex task, if you put it directly in agent mode, it sometimes goes and does the implementation before gathering enough data to proceed. Right. The next thing to understand is pricing model. So when we work with an LLM, we see here all this 3x, 1x, 0.33x. What do those mean? So that's the price you pay per model. It has a base price. So every provider has a base price. And for example, for Claude Sonnet, you have a base price of 1, and for Claude Opus is 3 times more expensive than Sonnet 4.6. But at a high level, the input-output costs are 3 times more expensive than input costs. Right, what is input and what is output? Now, input is what the GitHub Copilot sends to an LLM. So it gathers all those contexts, all the files, all the files, and all the what it needs to send a request to an LLM, or your prompts and all the files. And those are converted to tokens, and that's the input that we send to the LLM. Now, when the LLM responds to us, that's the output. So when it does code changes or when it responds to our prompt, that's the output, and it's 3 times more expensive than the input. Here is, you can see here how many now. You can even play with these models. So you can swap between them and do a test. Just type into prompt test and see how your number of tokens changes between the LLMs. It used to be that roughly 4 characters is a token. But once you play with these models, you realize that it has dramatically changed. For example, I've done an exercise the last week, and Sonnet 4.6, which I don't have it in this window, Sonnet 4.6 uses 3 times more tokens than Sonnet 4.5. Something to bear in mind and play with. All right, now menu options. In GitHub Copilot, there's the gear icon at the top, and if you click on it, you can see all the possible things you can do with GitHub, which is probably the most important one. So in GitHub Copilot, you can create custom agents, you can create skills, instructions, hooks, MCP, tool sets, plugins, and so on. Now we're going to go through a few of them in more detail shortly. But what I want to outline is sometimes these skills or the agents don't load or the instructions don't load. And to troubleshoot that, there is an option called Show Agent Logs. And when you click on that, it shows this image, it shows this panel here, which is an agent debug panel. And it tells you exactly which files and which instructions have loaded, and it does a troubleshooting of what source it has read in order to pick up that instruction and that instruction or that skill. So it's very good for troubleshooting. Now, probably the most important thing to consider is the context window. Now, LLMs have reached quite a significant limit in regards to the number of tokens. For example, Gemini has reached 1 million tokens limit, which is huge. But GitHub Copilot has a limit token. It used to be 128,000 tokens. They've increased it recently to 160,000 tokens. But the reason they keep it this small is because they know the more you send to an LLM, the worse it performs. So with LLMs, less is more. So that's why they keep this context so small. Now, what happens when you reach this limit of 160,000 tokens? Well, you have an option of, they've introduced recently this button called Compact Conversation, which you can do it manually. But GitHub Copilot does this automatically sometimes, not all the times, where it starts to summarize your earlier conversation with a prompt. And it compresses that, so it reduces the number of tokens. But sometimes it also eliminates the previous conversation or the previous files it read at the beginning of the history of the conversation. So if you type in your Copilot and you see that this one now turns red if you get into the limit. If you see it's getting red, you're not getting the right response. That means the context has removed some of the history and you will probably need to read files back. So this is for you to understand how it works and what happens if something just doesn't work as you expected. It's probably GitHub Copilot context window. Right. The other option we have in GitHub Copilot are tools. Now, in Visual Studio Code, it comes with a predefined set of tools, built-in tools like agent, browser. You can edit your file, read files, search through your workspace, and so on. What you can do here, you can build your own tools, yeah? And all, like I've done here with mine, this is a custom tool that I built, an MCP tool. There's also companies that have built their own tool, like Atlassian, which allows you to interact with Jira from your prompt, which is really, really good. I've done a live webinar on MCP tools. Can put the link in the chat if anyone wants to have a look. Now, how does GitHub Copilot work? It has multiple functionalities. It's a powerful tool, but at high level, for example, you are writing code and you are on a file that and it's automatically detecting the next change. Most likely, it's using fill in the middle feature. And what it does is it's using code before and after the cursor for better accuracy. So it sends code around your line of change. Then it's using a RAG system, and I've talked about this in another live webinar. To fetch relevant context, so to fetch relevant files, relevant to your prompt. And then it also blocks hard-coded credentials and common vulnerabilities. And as we know by now, it allows switching between models. Now, how does GitHub Copilot work in terms of files that get picked up when we type in a prompt? Right, so when we type in a prompt, the GitHub Copilot has an algorithm that decides which files is it going to read to help answer that prompt, because a prompt is an instruction to help fulfill that instruction. Now, first of all, it picks up the active file. So the file you're on IDE, you're working on a file that it's active, that one gets selected straight away. The next file that gets picked up is copilot-instruction.md, which is a very important file. This file sits at the root of the repo, and in this file you declare what your repo is about. What does your repo do? You can put in things like the structure of your code, what business logic you use, what ORM you use, anything that's useful for the Copilot to understand your code base. Yeah, it's like your new intern developer is coming in and you explain your code at a high level. That's what you need to include in here. Now, bear in mind, do not include lots of fluff, because as we know by now, for LLMs, it's better to have less because it reasons better. So send less tokens. The next file that gets picked up, if you have one, is name.instructions.md. Now, name here can be replaced by anything. Can be replaced by C#, can be replaced by Python, can be replaced by docs, can be replaced by JavaScript, anything. And we will see later how these files get picked up based on the language. So these are instructions specific for your domain. I want to have special instructions for PowerShell. I want to have special instruction for C#. This is the type of file you use. Now, the next interesting one is AGENTS.md. Now, AGENTS.md, it's the file that gets picked up when you run GitHub Copilot in agent mode. And usually what you put in here is, you can put in here things, what tools do you want your agent to use? For example, you can put in better search tools for your code repo. Or if you create a custom tool, a CLI that you wanted to use, you can put it in here. Right, then the next one in the order gets Open IDE tabs. So it scans the 20 most recent relevant open files. Again, here it's good to keep an eye on what tabs you have open, and if it's relevant for what you're doing. If it's not relevant, probably it's good to close them. And then what we are discussing about. So GitHub keeps on the file on your local computer a small rank system. And this rank system basically tells it, this project does this file does this functionality. And when you prompt it, for example, for a query for a database, it knows exactly where, which files to fetch that are related to database changes in your repo. And then it puts that in for input for the LLMs. And the last one is MCP servers. Now this one gets triggered when you instruct the GitHub Copilot to say, use this MCP tool to perform this task. So this is the last one. Right, so now let's dig a little bit deeper into what each of these functionalities, how do we register them, how do we construct them. So first of all is instructions and rules. So in order to add instructions for GitHub Copilot, in Visual Studio Code, we have to create a folder called .github. So this is read automatically by GitHub. And under it, a folder called instructions. And as I was saying before, it can be either docs.instruction or it can be python.instruction. And the way it knows how to apply each set of instruction per language is from this apply to. So the first section of the file, it's a YAML section, and it has a wildcard that filters based on files. So this is how it knows when to apply which instruction. Now, the next part is skills. Now, skills is very interesting. I use skills a lot in my workplace. And I use skills where I have small tasks that I need to produce. Like, for example, when I'm doing a build, or for example, if I want to run a test, that's when I'm creating a skill. I create a skill for just run this test or do this build and so on. Now, in order to add skills, there's this convention that we should be aware of. We have the folder called skills under .github, and under the skills folder, we create a new folder with the name of the skill. So for example, in this scenario, I have a skill called new fixture. And this skill for me, it adds a new test scenario in my code base. Now, inside this folder, you can put scripts. So your skill can call scripts that you customly made for the skill. But there's a must. We need to include a file called skill.md. It's actually uppercase skill.md. Inside this file, the YAML section has to have a name, and the name must match with the name of the folder. That's how it gets picked up. And then a short description of what the skill does. Now, this section here is extremely important because when you send a prompt in GitHub Copilot, what's good about skills is it doesn't load into context the entire skill.md, the entire file, because there will be too much context. But what it does, it loads the name and the description in the context, window. So when you type in, I want a new fixture for this, it knows from the name and the description to run this skill. So this is very important. Now, we can see here that my new skill has been picked up. So if you go at the gear icon at the top and press on skills, we can see my new skill here has been picked up. So this is how you test if your skill is getting loaded into the context window. All right, the next thing is prompts. Now, prompts are very useful because it's very good for user experience, and you can help the user do things that do complex things, and you create those prompts for them so they don't have to memorize a skill or anything like that. So in order to add a prompt, again, on the GitHub folder, on the prompts folder, the name of the prompt, it has to end in .prompt.md. That's how it gets picked up. This is the rule here. Inside the file, we put a description, and here we can configure tools. So this can be tools that are built in Visual Studio Code, or it can be tools that you created. Again, this is why it's so important to if you have your custom tools, to know that you can add it here as well. And you can also say, well, for this prompt, I want you to read this file, which is the skill that I've just added. So then it's very slick for us to have the confidence that if I type in the GitHub Copilot prompt, if I type in /new, it will show up my option or the prompt that I've just added. It will show up in here. Now, Visual Studio Code has a bug where it picks up the prompt twice. I do not know why, but it's a bug that I've observed. All right. Right, so let's see it in action, how it works. All right, so what I've just explained. So I am adding, I'm calling the prompt, yeah, new fixture. And you see how it's changed that prompt into an actual instruction. It says follow instructions in the prompt. And then what do I want to, what fixture do I want to, what test scenario do I want to implement? So I want to say, column does not exist in the DB. So we deployed code, but we didn't run the DB upgrade scripts. Just a little bit of background on what this project does. So this project is a root cause analysis system that uses agents to figure out what went wrong when you deploy something to production. And what I'm trying to do here is I have a skill that if I'm thinking of a test scenario that I want to implement, I can just call this skill, give it what failure test scenario I want to implement. I want to mock test data for, and then I just call it, and it figures out itself. Well, in skill.md, it has instructions on where to add data, what has been implemented so far, examples, and so on. So it reads those instructions and the files that are relevant. And then it goes and, creates a bunch of to-dos. And then it does implementation for me. It even runs the test. So all I have to do is check the code. That's all. Now imagine if I have to do this manually, having to prompt the Copilot every single time. I have to say, place this in this folder and run this test with this script and so on and so forth. So having this in one place saves me tons of time. It's a repetitive task that I can just do with a simple prompt. Now, the other thing to bear in mind is whenever I run a skill or an agent, I find that it's better to use Claude Sonnet than other models. So this is something to bear in mind. If you want the best performance from your skill or agent, try and use Sonnet so far. Right. The next part is agents. Now, this is something that is very fond of me because I love building agents. Now, we build agents when we have a complex task that requires a lot of reasoning, that requires complex navigation through the code, that requires, for example, if we have an if-else statement in the logic, then it's probably best to use an agent. If it requires a lot of reasoning and a lot of thinking, it's probably best to use an agent. Now, in order to use an agent, under the .github folder, create another folder called agents. And then the new agent that you want to create, it has to end in .agent.md. This is how it gets picked up. Now, inside the file, we can add description to the agent, what the agent does. And then we configure the tools. Again, the same as skills. We can put in the built-in tools available to Visual Studio Code, or we can, if we create our own MCP tool, we can configure it here, and we can add it here in the list, and it will automatically spin the MCP server for you when you start the agent. Now, once you added this agent, we can see here that when I click on agent, my custom agents show up. Yeah, so this is my new custom agent, add new connection. And this is very important because if you prompt Copilot to say, read this file, which is this one that I've just added, and execute it, you will find that it doesn't work as good as selecting the custom agent you just created. Sometimes it just goes and if you pass in the file by its path or its name, sometimes it goes and fetches other files. So it does things that you don't expect it to do. So the best thing to do is select your custom agent, then put your input and let it run. Right, let's see it in action. So the agent that I've created is my RCA system has to connect to different databases, for example, SQL Server or PostgreSQL has to connect to Datadog, New Relic. I want to implement several connectors, yeah, to my agent. And I want to have this option of the user being able to connect to different agents. Now, I don't want to do this every single time myself, manual. I don't want to prompt it where to add this new connection, how to add it, how to test it, and so on. So I've added this custom agent, which is add new connection. And we can see here it's in the list. So if I select the agent and I just pass in the input SQL Server, it will figure out that it has to implement a new connection called SQL Server. Yeah, she does so then it figures out, well, I need to gather some data from the user. Yeah. So it's going to ask me to gather some data. While it's waiting for my response, it goes and fetches more files that require to fulfill the instructions in the agent. And then I tell it, well, I want to extract from the database low query logs and wait stats, and then it's going to create a set of to-dos and do the implementation of what I've just asked for. Yep, so it's creating the JSON files, basically creating my mock data. Then it's writing unit tests for me. And then it's running the unit tests. Now, the good thing about this is if you let the agent build your project, build your code, run the tests, you will find that if it fails to build or if it fails to run, if one of the tests fail, it will automatically go and fix it itself. So you don't have to prompt it, fix my code or fix my test. It automatically goes and does it for you. So it's a very smooth process. You will do a couple of iterations. I think it does have a limit until it succeeds. Okay, now takeaways. Like I was saying, for LLMs, less is more. So try to keep the instructions files, the Copilot instructions files, the Agents.md. Try to keep it simple. Do not add things or do not add text that is not necessarily going to help the GitHub Copilot perform your instructions. And most important is to experiment a lot with LLMs and finding out what's best for each scenario. For example, from my experience, I can say that Sonnet is quite good for writing code, but it's not so great at writing documentation. It generates so much fluff, then I have to go and delete it and rewrite it myself. But I've tried GPT for writing documentation, and it keeps it simple. It keeps it straight to the point, and it helps me a lot in reducing all that fluff. That was it for today. Thank you very much. Any questions? I think that's it. Thank you very much.